Alright, so today we are going to be talking about limiting reactants. This is kind of the next piece that you need to know regarding stoichiometry. Now with limiting reactants, you've got two new pieces of vocabulary. We have this word limiting reactant right here, and we have excess reactant. Very simply, a limiting reactant is going to be completely used up. There's going to be nothing left of this in the reaction. And the excess reactant, you are going to have reactant that is left over. Okay, so there'll be some of the excess reactant left with your product. And that kind of goes back to what we talked about with the brownies. When we started playing around with the ratio of ingredients in the brownies, in some of the brownies that you decided didn't taste very well, very possibly had excess reactant sitting around in them. So let's take a look at how we do this. Here is a reaction for us up here. We've got nitrogen combining with hydrogen to produce ammonia. And I've got it balanced for you. Again, we're going to be starting with a balanced chemical reaction. And here's my question now. What if we react 4.0 grams of nitrogen with 2.0 grams of hydrogen? How many grams of ammonia will be produced? Okay, so how do I know this is a limiting reactant problem? How is it different from anything that you've heard before? Well, you have two amounts that are given to you that are both reactants. If you think of it, I've got 4.0 grams of nitrogen, 2.0 grams of hydrogen. These are both reactants in this equation. When you see that, you know you have a limiting reactant problem. The second reason, C number 1. Haha. So this is kind of what I like to try to do. I will write my amounts underneath each of the reactants. That will try to help me keep things straight. And what we need to do, the first thing you need to do is decide which reactant is going to run out first. In other words, which one is going to be completely used up, or the limiting reactant. There are three simple steps to do this. The first one, convert both masses to moles, which we know how to do. We've done that. That's kind of the first step of a mass-mass stoichiometry problem. So I'm going to use my periodic table, use the formulas, calculate the molar masses, and convert them to moles. The second thing that you do is you divide each mole amount by its reaction coefficient. So when I get my moles of hydrogen, I'm going to divide that number by 3. When I get my moles of nitrogen, I'm going to divide that by 1. The smallest value that I get is my limiting reactant. That's what's going to limit how long or how far this reaction goes. So let's do it. I've got 4 grams of nitrogen right here. I take that multiplied by 1 mole of nitrogen. The molar mass of nitrogen is 28.0 grams. Each nitrogen is 14.0, so 2 times 14, that's 28. 4.0 divided by 28.0 gives me 0.14 moles of nitrogen. That's divided by 1. And again, it's 1 because this is a 1 up here. And I get 0.14 moles. Do the same thing down here for hydrogen. I have 2.0 grams of hydrogen times 1 mole of hydrogen. The molar mass of hydrogen is 2.0 grams. That gives me 1 mole. That's divided by a 3 because there's a 3 in front of hydrogen in the reaction, and I get 0.33. Compare these two numbers. The smallest number is your limiting reactant. 0.14 is smaller than 0.33, so this is your limiting reactant, nitrogen. Hydrogen is your excess reactant. And what I'm going to do is I'm going to come back here, and this is what I'm going to use to start my stoichiometry. I could go all the way back to this, but I've already done this calculation, so I don't need to do it again. So let's figure out how much this amount of moles of nitrogen will produce of ammonia. I have 0.14 moles of nitrogen right here. That I'm going to take times 2 moles of nitrogen. That 2 is coming from right there, divided by 1 mole of nitrogen. That's coming from right there. And then this is the molar mass of ammonia, 14 for the nitrogen and 1 for the 3 hydrogens. That's a total of 17. So 0.14 times 2 times 17.0, that gives me 4.8 grams of ammonia. That's how much ammonia is produced. And I can also, at the same time, I can ask myself how much hydrogen is left over or in excess. So we can start again with the same number, 0.14 moles of nitrogen, and I'm just going to do it and find out how much hydrogen will react with it. So I'm going to take 3 moles of hydrogen. That 3 comes from the coefficient in the balanced equation, over 1 mole of nitrogen. That comes from the balanced equation. This is my mole ratio, times 2.0 grams of hydrogen over 1 mole of hydrogen. Okay, so 0.14 times 3 times 2.0 is going to give me 0.84 grams of hydrogen reacts. Okay? So if I started with 2.0 grams, let's do this color here. If I started with 2.0 grams of hydrogen, but only 0.84 grams reacts, then 2.00 minus 0.84 is going to give me 1.16 grams of hydrogen would be left over at the end of the reaction. Does that make sense? Good. I'm glad. From the quiz, let me give you another problem and see if we can do this for tomorrow. I'd love for you to come in to class tomorrow with either an answer or a question about how to do this. So here's your problem. If you have 2.0 grams of oxygen and it's combined with 1.0 grams of magnesium to produce magnesium oxide, what is the limiting reactant and how much magnesium oxide is produced? Okay, that's just like what we went through on this video. So let's see what we get for it for tomorrow. Thank you.